Assalamu alaikum. Today we are looking at May 2024 Unit 2. We'll look at some specific questions that were requested by some of our students. Let's move on to section number A. Section number A, question number 3. It says, which equation represents the reaction for which the enthalpy change del RH, enthalpy change of reaction, is the mean bond enthalpy of the CCl bond in CCl4. It says that this is the mean bond enthalpy of the CCl bond in the CCl4 molecule. Which del H represents the mean bond enthalpy of the CCl? It would be option B, because in option B, 4 moles of CCl bonds were broken, right? 4 moles of CCl bonds were broken. Now, if you break 4 moles of carbon-chlorine bonds, so this reaction, in this reaction, 4 moles of CCl bonds were broken. Now, if you divide this reaction by 4, see, there's 1 by 4. There's 1 by 4 as coefficient for CCl4. It means if you multiply this equation by 1 by 4, you get the average value for the carbon-chlorine bond. Because when you look at CCl4 has 4 carbon-chlorine bonds, right? Now, the total energy required to break 4 moles of bonds, if you divide by 4, 4 moles of these bonds are broken, and the total energy required to break 4 moles of bonds, if you divide it by 4, you get the average bond enthalpy, you get the mean bond enthalpy. All right. Number 4. It says which isomer has the highest boiling temperature? The isomer which is unbranched will have the highest boiling temperature, right? All the compounds, I think, contain the same number of carbon atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All the isomers here, they contain the same number of carbon atoms. So they have the same number of electrons, but they have different surface area because compound A is unbranched, the other compounds are branched, right? And that is why A has the highest boiling temperature. Then we move on to question number B, which says which compound has the highest boiling temperature? Of course, B will have the highest boiling temperature because B has 2 OH groups in it. Since B has 2 OH groups in it, it produces more number of hydrogen bonds. A is non-polar, B is non-polar, they don't have hydrogen bonds. C is polar, C has OH in it, so C can form hydrogen bonds. But D is a diol, it has 2 OH groups, so it forms greater number of hydrogen bonds than C. That is why D will have the highest boiling temperature. Then we move on to question number 6. It says, what are the products formed when lithium nitrate and calcium nitrate are heated separately? If you heat lithium nitrate and calcium nitrate separately, if you heat them separately, if you heat lithium nitrate, it produces lithium oxide, nitrogen dioxide, and oxygen. And if you heat calcium nitrate, it produces calcium oxide, nitrogen dioxide, and oxygen. So that matches with option number D. But you need to remember this. You must remember what happens when these compounds are heated, right? Then we move on to question number 9. It says, which compound exactly needs 9 moles of oxygen for complete combustion of 1 mole of the compound? 9 moles of O2, right? So if you carry out a combustion of C5H12, it will produce 5 moles of carbon dioxide. And 6 moles of water, right? Because there are 5 carbon atoms, so 5 moles of carbon dioxide, 12 hydrogen, so 6 moles of water. So the number of oxygen required will be 5 into 2 will be 10, plus 6 will be 16. So the oxygen required will be 8 O2, right? If you carry out combustion of C6H12O, it will produce 6 moles of carbon dioxide and it produces 6 moles of water. So the number of oxygen required will be 6 into 2 is 12 plus 6 is 18. So there is already one oxygen. So this would be 17 by 2 O2. So that becomes 18, right? This would be 6 CO2. Sorry, I wrote wrong. Now C6H14, if you react with oxygen, it will produce 6 moles of carbon dioxide and it will produce 7 moles of water because there are 14 hydrogen. So it will form 7 moles of water. So if you look here, the total number of oxygen required would be 6 into 2 is 12 plus 7, which is 19. So you require 19 by 2 O2 oxygen, 19 by 2 moles of O2. So we are left with D, right? So D is definitely the answer. If you react D with O2, it will produce 6 moles of carbon dioxide and will produce 7 moles of water. So the number of oxygen atoms required will be 6 into 12 plus 7, which is 19, right? You need 19 oxygen atoms, right? So there's already one oxygen, so you need 18. So you need 9 moles of O2. So therefore D is definitely the answer. All right. Question number 10, it says which solution remains clear on addition to barium chloride? It's sodium nitrate because all nitrates are soluble, right? Now if you add sodium nitrate to barium chloride, they don't form a precipitate. If you add them, they will form sodium chloride, which is soluble in water. They will form barium nitrate, which is also soluble in water. Now if you add sulfuric acid to barium chloride, so barium and sulfate will form a white precipitate. If you add silver nitrate to barium chloride, so silver and chloride will form silver chloride, which is the white precipitate. If you add sodium sulfate to barium chloride, the sulfate ion and the barium ion will form barium sulfate, which is also a white precipitate. The answer would be C. Then we move on to the next question. 11b, it says what is the concentration of potassium sulfate produced by the reaction at the end point, and you have to give the answer to two significant figures. You have to find the concentration of the potassium sulfate solution. So initially what you do is you should find the moles of potassium hydroxide or sulfuric acid. You can find the mole of any one of them because they would have the same number of moles. Or no, not really. We should find the number of moles of both and figure out no, they should have the same number of moles, yeah. This is fully new. So you can find the moles of any one of them. For example, you find the moles of maybe potassium hydroxide. It will be 0.8 multiplied by 25 into 10 to the power minus 3. From there, you find the moles of potassium sulfate. Now for this you need to write the equation for the reaction. So the reaction was between sulfuric acid and potassium hydroxide. When sulfuric acid and potassium hydroxide react, they form potassium sulfate and they form water. If you want to balance the equation, you have to give 2 here. This is the mole ratio is 1:2, right? So since we have found the moles of potassium hydroxide, the mole ratio of potassium hydroxide is to potassium sulfate is 2:1. The mole ratio of potassium hydroxide to potassium sulfate is 2:1. So the number of moles of potassium sulfate would be half, right? Moles of potassium sulfate will be equal to half multiplied by 0.8 multiplied by 25 into 10 to the power minus 3. Then you find the concentration of K2SO4. Concentration of K2SO4 will be equal to moles of the potassium sulfate. The moles of the potassium sulfate divided by the total volume of the reacting mixture. Now what is the total volume of the reacting mixture? Let us see. Because when we carried out this titration, the total volume was found to be 35, 10 cm cube and 25 cm cube. The total volume was found to be 35. So you divide this by 35 into 10 to the power minus 3. So, and if you calculate this, it is found to be 0.29 moles per dm cube. Alright. We move on to the next question. It says bromine and chlorine each have two stable isotopes, 79, 81, 35 and 37. Which of the statement is true? It says the atomic radius of bromine 81 is greater than that of bromine Br 79. That's wrong. They just have a difference in their mass. They have different number of neutrons. Their mass is different. They have the same atomic radius because they have the same number of electrons. Electronegativity of chlorine 35 is greater than that of chlorine 37. No, they have the same electronegativity because they have the same number of protons. They have the same attraction for the bonding pair. The mass spectrum of this has two molecular ion peaks. This will have more than two molecular ion peaks because there's bromine and chlorine. Each has two isotopes. So just a minute, boy. Have I? Sorry. Voice message. এটা কি আপনি আনছিলেন না আমি আসছি ওকে আপনি খেলেন সমস্যা আপনি কাম সমস্যা না আমি আনলাম কিন্তু সকালে না তাহলে আপনি খান সমস্যা না আপনি লাগবে আপনি নেন সরি ফর দ্য ইন্টারাপশন তো যেটা বলতেছিলাম the mass spectrum of CH2BrCl has two molecular ion peaks. See, it will have more than two molecular ion peaks because each halogen here contains more than one isotope. Because bromine has two isotopes, chlorine has two isotopes, right? So there can be different combinations of bromine and chlorine. For example, there can be a combination 7935. There can be a combination of 8135. There can be a combination of 7937. There can be a combination of 81 and 37. So, right, so there can be more than two combinations. So there will be more than two molecular ion peaks. Now it says the first ionization energy of Cl is greater than that of Br, of course, because as we go down the group, the ionization energy decreases. Now bromine is below chlorine, right? So definitely the ionization energy decreases. Number 15. Number 15, it says, 15b, right? For container 3, at the same temperature as container 1, the pressure is lower. Okay, the pressure was lowered. Pressure usually is lowered by decreasing the number of moles, right? Or decreasing the number of particles. If you decrease the number of particles or the number of moles, the pressure would be lowered, right? For which values the number of particles at that value change. If you lower the pressure, the number of particles would decrease. The total number of particles would decrease, right? So if the total number of particles decreases, the whole curve would now look smaller. It will look smaller because the total area of the curve would be less because the number of particles would be less. Because you have decreased the pressure, so the number of particles would be less, right? Because the pressure is decreased. So the curve would look like this. So the number of particles at E mode would be less. Number of particles at E mean will also be less because previous it was here, it decreases to here. Previous it was here, it decreases to here. The number of particles at the activation energy will also decrease from here to here. So your answer would be D. D would be the answer. They did not ask about whether activation energy decreases. They did not ask about whether these values would decrease. They asked about the number of particles that would decrease. They are asking about these numbers, whether these number of particles would decrease or not. So if you decrease the pressure, the number of particles decreases. So the overall curve would look smaller. So definitely the number of particles in these regions would also decrease. Next question. Move on to section B. We move on to question number 18b. It says state the meaning of the normal numerals in chloride 5 and chloride 7. Now in chloride 5 it means in chloride 5 means that the oxidation number is plus 5. Chloride 7 means, it's a very easy question. The chloride 7 means that the oxidation number is plus 7. You should write that the oxidation number of chlorine is plus 5. Yeah. Oxidation number of chlorine is plus 7. You have to find the oxidation number of chlorine in the chlorine dioxide molecule. The oxidation number of chlorine in the chlorine dioxide molecule will be plus 4. I think you could figure this out. Chlorine dioxide has the formula ClO2. So you find the oxidation number of chlorine. So let us assume the oxidation number of chlorine to be X. So X plus, there are 2 oxygen atoms, so write 2 here. Each oxygen has a charge of -2 usually. So -2 equals 0 because the total charge of this molecule is 0. So you find X is found to be plus 4. And that is why the answer to this question will be plus 4. All right. Then it says in step number 2, compound A undergoes disproportionation. It says compound A undergoes disproportionation to form chlorine dioxide and hydrogen chloride 7. It disproportionates to form chlorine dioxide and hydrogen chloride 7. So A disproportionates into, see, we don't know what A is. We don't know the compound A, but it disproportionates into ClO2 and it produces hydrogen chloride 7, right? It says deduce the possible range of oxidation numbers for the chlorine in compound A. The range of oxidation number in compound A, what should be the range of the oxidation number? Now it says it disproportionated, right? Now the oxidation number of chlorine in ClO2 is plus 4. And the oxidation number of chlorine in HClO4 is plus 7. Oxidation number of chlorine here is plus 4 and oxidation number of chlorine here is plus 7. So if the chlorine in A gets disproportionated, it must, the oxidation number of the chlorine in A, in compound A, must decrease and also must increase, right? So the oxidation number of A must be greater than 4 and less than 7. So the oxidation number of chlorine must be between 5 and 6. Oxidation number of Cl in compound A must be either 5 or 6. How do you justify? Because reason is, as A gets oxidized, sorry, I wrote wrong. As the Cl in compound A gets oxidized to plus 7 and also gets reduced to plus 4. So the oxidation number of chlorine A must be between 4 and 7, right? We move on to question number 19b. It says, what happens to the equilibrium mixture containing ethanol so that the overall yield of ethanol becomes 95%? So usually this is a very common question in the exam. They always ask this question. What happens to the equilibrium mixture when we, how do we increase the yield? Usually the yield is, the conversion is only 5%, but the overall yield is 95%. How is it possible? If the original percentage yield was 5%, what was done to increase it to 25%? The best way to increase the yield is to remove the product as soon as it forms. You remove this product as soon as it forms. If you remove this product as soon as it forms, the position of equilibrium will shift to the right. It will keep on shifting to the right because you are removing the product continuously. So the concentration of the product on the right hand side of ethanol would be less, will always be less. because we are removing it as soon as it forms. So the position of this equilibrium will always be shifting to the right. It will keep on moving to the right. So the yield will be much higher. So you remove this, or you say you have liquefied this compound. If you liquefy this, the concentration of the gas would decrease, right? So the position of equilibrium will shift to the right. So there's one way, right? Another way to increase the yield is to recycle the unused reactants. The reactants which are not reacting, if you recycle them, if you keep on adding them here, the concentration of these two increases, of these two substances increases. The concentration of these two substances would increase. So the position of equilibrium will also shift to the right. So your answer would be, let us look at the answer. Now if you remove the ethanol, so I've already written the answer here. Ethanol is removed, or the ethanol is liquefied. So the position of equilibrium shifts to the right. So the yield increases. And the unused reactants are recycled. If you keep on feeding the reactants, the unused reactants here, the equilibrium will also shift to the right. So therefore the yield would increase. Right? Then we move on to the next question, which is question number 2. It says, explain why a manufacturer might suggest a pressure of greater than the compromised temperature of 7 megapascals. Because if you increase the pressure, so if you look at the reaction here, if you increase the pressure, since there are more moles of gases on the left, which is 2 moles, and less moles of gas on the right, so there's 2 moles on the left and 1 mole on the right. So if you increase the pressure, the position of equilibrium will shift from left to the right. If you increase the pressure, the position of equilibrium will shift from left to the right. So the yield would increase, right? Because there are fewer moles of gases on the right hand side. So that's the answer that we would write here. I have already written the answer for you. So at a greater pressure, the position of equilibrium shifts to the right, which increases the yield of ethanol. And why do the equilibrium shift to the right? Because there are fewer moles of gases on the right hand side. So an increase in pressure shifts the equilibrium to the right, as there are fewer moles on the right hand side. At pressures greater than 7 megapascal, a waxy solid forms which melts over a range of temperature. Whenever it says a solid melting over a range of temperature, you should know that it's a polymer. Because polymers don't have a fixed melting temperature. Because polymers have very long carbon chain. So they softens over a range of temperature, or it melts over a range of temperatures. Whenever they talk about melting over a range of temperatures, solid melting over a range of temperatures, you should know that they're talking about a polymer. Because if you give too much pressure, so what happens? We have ethene as the reactant. So if you give too much pressure, ethene may undergo polymerization, because polyethylene is formed under high pressure and high temperature. So at very high pressure, ethene may turn into polyethylene. So that is why the answer to this question is polyethylene. We move on to the next question. It says, one advantage and one disadvantage of increasing the amount of water. If you increase the amount of water, the advantage is that the yield of the product will be greater, because if you increase the amount of water, so the concentration of H2 will be greater. So the position of equilibrium will shift from left to the right. So the concentration of the product will increase. Equilibrium will be shifting to the right. So the concentration of the product will increase, right? Alright? And what is the disadvantage? Disadvantage is that if you give more water, your product, the main product is ethanol. So if you give more water will be present in ethanol. More of the water will be present in ethanol. And it will be difficult for you to remove water from ethanol, because there is already too much water, because you've added too much water. Because the product mixture will always contain water with ethanol, because ethanol is soluble in water. So if you give too much water, the ethanol water mixture or the product mixture will have way too much water. So it becomes difficult to separate, because we will have to separate ethanol from water, because we need ethanol and not water. So the answer would be, let me show you the answer. I've already written the answer. Where's the answer? Here's the answer. Let us look at the answer. It says the position of equilibrium shifts to the right, so the yield of ethanol increases. Disadvantage, product mixture is more diluted, that is more water needs to be removed from ethanol. Now we move on to the next question, question number 20. It says, give the IUPAC name for isoprene. Let us look at isoprene. Isoprene is this compound. If you look here, there are 1, 2, 3, 4 carbon atoms in the longest chain. So there's carbon number 1, that's carbon number 2, carbon number 3, carbon number 4. Right? So there's a double bond between carbon number between 1 and 2 and between 3 and 4. And there is a methyl group on carbon number 2. So this is the longest chain. And that's the alkyl group, right? Alkyl group on carbon number 2. So if you look at the longest chain, there are 1, 2, 3, 4 carbon atoms. So we'll write bute, because there are 4 carbon atoms in the longest chain, 1, 2, 3, 4. Now there is a double bond in carbon number 1. So we write bute 1. There's a double bond on carbon number 3. So we write bute 1, 3. There are 2 alkenes. So we write diene, because if there are 2 alcohols, we write diol. If there are 2 alkene functional groups, we write diene. So it's bute 1, 3 diene. And there is a methyl group on carbon number 2. So we write 2 methyl bute 1, 3 diene. And you must remember, there must not be space between methyl and bute. So it will be called 2 methyl bute 1, 3 diene. Sorry, the next question, it says the peaks with the highest intensity in the mass spectrum of isoprene are at m by z equal to 68 and m by z equal to 53. If it is m by z equal to 68, let us look at the molecular formula. The molecular formula would be 1, 2, 3, 4, 5. There are 5 carbon atoms, C5. Let us look at the molecular formula. There's 3 hydrogen here, 2 hydrogen here, 1 hydrogen here, 2 hydrogen here. So 3 to 5, 6, 7, 8. There are 8 hydrogens. C5H8 is the molecular formula. Yeah. So the molar mass of this compound, if you find the molar mass of this compound, is found to be 68. C5H8 is the molecular formula of isoprene, and the molar mass is found to be 68, right? It says species responsible for these 2 peaks. The m by z equal to 68. 68 is the molecular ion peak, because 68 is the molar mass. So this would be the molecular ion peak. So this whole thing, you write the whole thing and give a plus charge. That would be the species responsible, right? So this would be, let us draw the structural formula. This would be CH3. This would be C double bond CH2. This would be CH double bond CH2. So this is the structural formula of this compound. This is the structural formula of isoprene. You give a square bracket, you give a positive charge. Your answer is wrong if you don't give a positive charge, because the species responsible has to be a cation. Then it says m by z equal to 53. If you look at m by z equal to 53, what you can do is this is the molar mass, right? 68. And if you look at the difference between 68 and 53, the difference is 15. From 68 to 53, the difference is 15, right? The mass number 15. The 15 is represented by CH3. So if you remove CH3 from 68, it becomes 53. So the next species that you draw is C double bond CH2, CH double bond CH2. You give a plus sign here. Or you can simply give a square bracket and give a plus sign. So this species is responsible for m by z equal to 53. This species is responsible for m by z equal to 68. Then we move on to question number 3. State the origins of the peaks labeled P, Q and R. You may use a label diagram. Now, if you want to find P, Q and R, you have to look at the data booklet. I have already bring this part of the data booklet here. This represents the absorptions, the well number for the different absorptions from the data booklet. So let us look at P. P is around 2900. Q is around a bit more than 3000, and R is around, let's look at R is around, that's 11, 12, 13, 14, 15, 1600. That's 1600, right? So let us look at 1600 at R. 1600. This is about which compound? Of isoprene. Oh, this is for isoprene. Okay. This is for isoprene, for this compound. So this compound has CH and carbon-carbon double bonds only, right? So we'll look for CH and CC bonds, right? So if you look at alkane, here, it is between 2900 to 2800, right? So we got something between 2900 and 2800. So that's Q, right? Q is within this range, right? Okay. So we can write Q is CH for alkane. Then we have the 3095 to 3010 for alkene, right? So this is very close to 3100, right? 3095 is very close to 3100, so we can write this is for CH. In bracket you write alkene. Okay. Another absorption that we found was at 1600. Let us look at 1600. 1600, we got 1600. 1600 is for the alkene, for the carbon-carbon double bond. Here, for the alkene, for the isolated alkene, 1669 to 1645. So this is around 1600, right? R is very close to 1600. So this what we should write here is that this is carbon-carbon double bond for alkene. This should be our answer. All right. Then we move on to question number B1. It says, show that myrcene and limonene are terpenes by comparing the molecular or empirical formula of myrcene, limonene, and isoprene. Now let us see what are terpenes. I think it was given in the question. It says terpenes are made up of two or more isoprene units joined together. So in order to be a terpene, two or more isoprene units should join together, right? So minimum of two isoprene joined together, you get a terpene. Or more isoprene molecules joined together, you get terpenes, right? So these molecules are called terpenes when isoprene molecules, two or more isoprene molecules are joined together. So if we look at myrcene and if we look at limonene, let us find the molecular formula of myrcene. Myrcene has how many carbon atoms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So myrcene has 10 carbon atoms. Let us look at the hydrogen. They have three hydrogen. There's 1, there's 2, there's 2 hydrogen, there's 1 hydrogen, there's 2 hydrogen. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 hydrogen atoms in myrcene. Let us look at limonene. Limonene, I think they have the same number of carbon atoms. They should have the same number of carbon atoms. Let us count the number of carbon atoms, though. It will be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let us count the number of hydrogen. 3. 1, 2, 1, 2, 2, 3, and 2. So there's 2, 2, 2, 6, 6. Then 3 is 9, 10, 11, 12, 13. 13 plus 3, 16. So this is also 8, 16, right? Now let us look at the molecular formula of isoprene. We already found the molecular of isoprene. Molecular formula of isoprene was found to be C5H8, right? This is C5H8, right? So now the empirical formula. So in the answer you should write that the empirical formula of both of both myrcene and limonene is C5H8. Right? So which means myrcene is made from 2 units of isoprene. It means limonene is also made from 2 units of isoprene. So each compound is made from 2 units of isoprene, which has isoprene C5H8. You should also give the molecular formula. I think it's best to give the molecular formula of these compounds as well. Empirical formula of both myrcene is C10H16, and limonene C10H16 is C5H8, which indicates that each compound is made from 2 units of isoprene, which has the formula C5H8. Right? This should be your answer. Next question. 5 grams of myrcene and limonene were completely hydrogenated. Calculate the total volume of hydrogen required to hydrogenate each sample. So 5 grams of myrcene was hydrogenated. So what you do is you find the moles of myrcene will be mass divided by the molar mass. The molar mass of myrcene, we found the molar mass of isoprene. So molar mass of myrcene will be 68 times 2, right? Because they have the formula C10H16, right? Or you can find the molecular formula, which is C10H16. So this will be 5 into 12 plus 16. That would be the, that's how you find the moles of the myrcene, right? So if you calculate the number of moles of myrcene, so this would be 60 plus 16, right? 60 plus 16. So, sorry, my bad. It is C10, right? So this would be 12 into 10 plus 16. This would be the molar mass of myrcene, 12 into 10. This would be 120 plus 16 is 136. So 5 divided by 136 will give you 0.4044. All right, this would be the moles of myrcene. Okay. I think I made a mistake here in the calculator. That's not 0.4044. This would be 5 divided by 136. Sorry, I wrote 55. This would be 0.0368. This would be the moles of myrcene. From the moles of myrcene, we find the number of moles of hydrogen gas required. Moles of H2 required for complete hydrogenation. Now let us look at the structure of myrcene. Myrcene has 1, 2, 3 double bonds. So the number of moles of hydrogen required will be 3 times the moles of the myrcene, because the mole ratio will be 1:3, because there are 3 double bonds. In order to saturate 1 double bond, we need 1 H2. In order to saturate 3 double bonds, we need 3 H2. So you multiply by 3. So now if you multiply by 3, it is 0.0368 multiplied times 3. This would be 0.1104. Right? Then you find the volume of hydrogen, 0.1104 multiplied by 24 dm cube or 24,000 cm cube. You get the answer in cm cube. So if you multiply, let me multiply 0.1104 into 24,000. It would be 2650 cubic centimeters. All right. Then we find the moles of limonene. Moles of limonene will be 5 divided by the moles of limonene. So moles of limonene will also be the same, because they have the same molar mass, will be 0.0368. From there you find the moles of hydrogen gas. So if you look at the structure of limonene has 2 double bonds only, so the mole ratio will be 1:2. Because limonene has 2 double bonds, it will require 2 moles of hydrogen. So the moles of hydrogen gas required will be 2 multiplied by 0.0368. So if you multiply 0.0368 times 2, this would be 0.0736. Now if you find the volume of H2, it will be 0.0736 multiplied by 24,000. So this would be 1766 cubic centimeters. This would be the answer. All right. Then it says give the IUPAC name formed by the complete hydrogenation of myrcene. If you carry out complete hydrogenation of myrcene, there won't be any double bonds here. These double bonds won't be there, right? So there won't be any double bonds. So the structure would look like this actually. Let me show you the structure. The structure would look like this. Look at the structure again. No double bond and no double bond here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. This would be the structure. There were double bonds here. So these there were double bonds here. So these double bonds won't be there anymore, right? So now if you want to write the name, if you look at the longest chain, there's 1, 2, 3, 4, 5, 6, 7, 8. So we'll name it octane because it's an alkane, because it's completely hydrogenated. It is octane, it is an alkane. There are 2 alkyl groups, one on carbon number 2, one on carbon number 6. So you write dimethyl. So one methyl group on carbon number 2, one on 6. So this would be called 2,6 dimethyl octane. This would be the answer. All right. Now we move on to question number C. It says 3 students were asked to carry out a single chemical test to ambiguously identify the presence of the OH group in the 3 terpenoid compounds, menthol, linalool, and citronellol. Okay. They are testing for the presence of OH group. First student tried using acidified dichromate to oxidize the alcohols. So this would not totally work, because potassium dichromate will oxidize menthol because it's a 2-degree alcohol. It cannot oxidize linalool because it's a 3-degree alcohol. It can oxidize citronellol because it's a 1-degree alcohol. So using potassium dichromate, you can identify OH in menthol and citronellol and not the OH in linalool. The second tried potassium manganese 7, an oxidizing agent similar to potassium dichromate. If you use potassium manganese 7, all the 3 compounds will turn the potassium manganese 7 from purple to colorless. All the compounds will turn potassium manganese 7 from purple to colorless. All of these will turn from purple to colorless, because camphor will oxidize all of them. Because it's a 2-degree alcohol, it will get oxidized by potassium manganese 7. It's a 1-degree alcohol, it will also get oxidized by potassium manganese 7, but it also contains, for example, linalool is a 3-degree alcohol, but it contains double bonds. Now potassium manganese 7 can also oxidize double bonds. And that is why using potassium manganese 7, you cannot actually prove that whether OH bonds are present or not, because it can also oxidize. It also gives the same observation if double bonds are present. Now if you look at the third student, it says the student used PCl5. Now this student was correct, because PCl5 will only react with compounds that have OH in them. So the presence of OH group can be clearly be found or can be clearly be identified using PCl5, because PCl5 will react with all the OH, whether it's primary, secondary or tertiary. It will give you steamy fumes with any compound that contains OH in it. So I have the part of the mark scheme here where all the points are given. So it was a long answer, so I didn't write, rather I took a screenshot of the marking scheme. It says dichromate will go from orange to green with menthol and citronellol, but would not go green with linalool, because menthol and citronellol can be get oxidized because they are primary and secondary. Linalool is tertiary, it cannot be oxidized, so there is no color change. Right? So potassium manganese 7 will go from purple to colors with all three, but it also reacts with carbon-carbon double bond. So therefore it's not a good choice. PCl5 is the best choice because PCl5 will produce misty fumes with all, and it identifies OH only. So whether it's primary, secondary or tertiary, PCl5 will react with all of them. Clear? So that's how you write the answer. And you should, since it's a star mark question, you should answer. Your answer should have a structure. So you write about dichromate in one paragraph. You talk about potassium manganese 7 in another paragraph, and you talk about PCl5 in another paragraph. So your answer must always be structured. Otherwise, you'll be losing 2 marks from this 6 mark question. And I think that's the end of the paper. Yeah, that's the end of the paper. Thank you.